Quiz 3. So first step for this first question was to label the chiral centers. So again, these are going to be sp3 hybridized atoms bonded to 4 different things, right? And a lone pair doesn't count as 4 different things. So a lot of folks thought that this would be like a nitrogen would be, but it can't be. So you're looking for places where things come together, right? If you see an atom with 4 things on it, that's a good spot, or 3 carbons bonded to it, that's usually a good spot to look, where things come together. So there's 1, 2, 3, 4, 5. Folks got thrown off on maybe on this one a little bit because there's 2 methyls, but those are the same, or the nitrogens, they got thrown off, but lone pairs don't count as 4. So this second one, number all the atoms except the H's. So you gotta remember to, if I ask you to number the atoms, make sure you number the atoms. Didn't matter how you numbered them. Probably should have different numbers for each piece. Add lone pairs. So 2 lone pairs in this nitrogen, 1 on this one. Formal charges. There's a negative charge in this nitrogen, only has 2 bonds, right? Assuming full octets. Plus charge here. This is actually called click chemistry. This is what the Nobel Prize in Chemistry was awarded for this last year. Professor Carolyn Bertozzi will actually get to do this lab next semester. If you take OChem 2, you'll do this kind of lab. It's really important chemistry that works in biological systems. So it's usually how you do all the protein tagging, as one example. But once you do this, it's just 3 arrows. So the nitrogen with the negative charge is probably where your first arrow should start. That's the nucleophile, electron rich. That goes to carbon 3, which you should have had seen here. That causes the pi bond to break between 3 and 4, and 4 now bonds to nitrogen 7. And that nitrogen's pi bond breaks between nitrogen 7 and 6. And those electrons go to 6, and you get a lone pair there, and this is what you get your final product. This is all catalyzed by copper, but you don't need to know that yet. Rankings, hopefully fairly straightforward. Again, I saw people trying to rank all 4 of these things. Don't do that. Right, you split it in half and you rank this position, the 2 things off it. So carbon to carbon, that's a tie. Carbon to fluorine, the fluorine wins. Here, nitrogen to carbon, nitrogen wins. It doesn't matter, the phosphorus is way out here. But I saw a lot of people try and do red, white, and blue stuff with this, right? With alkenes, it has nothing to do with RNS. Next piece, again, now this is RNS. This is asking you to draw it as R. Alright, so to do RNS though, so this one asks you to do R, and so you're given a structure without any wedges and hatches, and you need to put wedges and hatches on there. So to do this, you first got to do the rankings. So oxygen has priority. The other ones are carbon, carbon, carbon. It's a tie. This carbon is bonded to another carbon and 2 H's. Carbon, 2 H's, so that's a tie. This is bonded to 3 H's, so this is 4. Now these will go out 1 more bond. Carbon, 3 H's. This one wins. So now we have the rankings correct. Now you grab your model and you put the wedges and hatches in. There's lots of different ways to do it. This is one way. So you said red, white, and blue. So this is R. So rankings and wedges and hatches. For this one, kind of a mechanism SN2 question. Again, had lone pairs, formal charges, every lone pairs in, right? Really checking to make sure you understand how many bonds things want to have. Assume full octets. You should recognize a couple things here. There's a substitution, and there's an inversion. That means it has to be an SN2. Reactive nucleophile also gives that away. You need to show it coming from the back side. Folks, be careful where you put your charges. Make sure it's on the atoms, not floating out somewhere. That's the other thing I noticed quite a few folks would do as well. So make sure you have those things kind of locked up.